Have you ever felt stuck in math, like no matter how hard you try, some concepts just don't click? What if I told you that just understanding one simple idea can make math feel easier, more intuitive, and even boost your confidence? And that idea is the dual nature of math, a fundamental balance built into everything from basic arithmetic to advanced calculus. Once you start recognizing these patterns, you'll start to see math differently. You won't just memorize steps, you'll understand why they work, making it easier to grasp new concepts and solve problems creatively. The goal of our math videos is to help you unlock this deeper understanding. By exploring how math is structured, you'll gain skills that make problem solving smoother and more natural. Math is built on balance, equal but opposite relationships. And we see this all around us in the real world, in English, when we can't have bad without good. We've got this balance to everything, dark and light. Math is the same way because it's derived from nature. And we see this from the very beginning with some basic arithmetic. So level 1 math, first stuff you learn, addition and subtraction, two sides of the same coin. And when you get better at it, you start recognizing that you can even write subtraction problems as adding a negative, and vice versa. There's a whole bunch of interchange between the two. Then we move on to level 2 math, multiplication and division. Multiplication's just repeated addition, and division just undoes multiplication. Two sides of the same coin. And then we move on to level 3, exponents and radicals. Exponents extend multiplication and radicals undo them. And just like with subtraction and adding, you can kind of go interchange between the two of them depending on how you like to visualize a problem. Instead of dividing, we can multiply by a fraction. And instead of having radicals, we can raise a number to a fractional exponent. So they are interconnected in ways that allow us to manipulate numbers with more creativity. Understanding this flexibility makes math feel less like memorization and more like a logical system that you can navigate. We also have a duality in numbers and expressions. We got positive numbers. I like thinking about it as like we got the light side, and then negative numbers, the dark side. And they're opposites that cancel out when they're combined. They're opposing forces. We also have fractions that also have a balance to it. If the numerator and the top and the denominator, the bottom, are the same, they cancel out, it all turns to 1. So there's a balance between the top and bottom of the fractions as well. In algebra, this concept becomes even more useful because then we have moves that we can make that work with this balance. The distributive property and factoring are essentially inverse processes of each other. The distributive property expands expressions. It's like if you have Legos and you start building with it. And factoring breaks expressions down into their building blocks, like taking apart a Lego creation to see how it was made. And we can go back and forth. We're not changing anything except we're seeing the components, we're seeing the individual parts, then we're seeing the whole picture. Often students struggle with these topics because they're taught separately without emphasizing their connection. But once you see them as two sides of the same process, they become much easier to work with. And they encourage the creativity in math because you're just building with numbers and taking them apart. This keeps going through advanced mathematics as well. If we get into the high school levels, we see this duality again in derivatives and integrals. Derivatives, for me, it's like zooming in on a function, allowing you to find the rate of change at any single point. While integrals is like zooming out, taking a different perspective, calculating the total accumulation over time. This zooming in and out and changing of perspectives helps us analyze motion, growth, and patterns in the world around us. So how does this matter in the real world? Well, it mirrors the real world. Think about some of the things that you love doing or some people are super interested in. Just as mechanics must take apart and rebuild machines to understand them, mathematicians must deconstruct and reconstruct numbers and equations. This flexibility is what makes math so powerful, not just as a subject, but as a tool for critical thinking. And beyond math, this idea of balance is everywhere. If we look to nature, it's filled with dualities, light and dark, action and reaction, expansion and contraction. Recognizing this balance in math helps us see it in the world, making problem solving more intuitive. So as you go through your math lessons, try to recognize these relationships. Instead of memorizing steps, seeing them as distinct parts and new concepts, look for the underlying balance of things. This is not only going to strengthen your understanding, but enhance your ability to think flexibly and solve problems in creative ways. We'll continue exploring these ideas in future videos, zooming in on specific skills and strategies, going through each one of these to help you see math in a whole new way and move forward with more confidence.